Okay, everyone, so for these video notes, we are going to be talking about the 6 different types of chemical reactions. This is learning target 5-2. Make sure that you've got out your notebook and that you are taking some good notes here because we are going to be referencing these notes you're about to take a lot in class, so I will be asking to see them. The first thing to write down is this slide here, the 6 common types of chemical reactions. First up, we have a synthesis reaction, and we say that a synthesis reaction is like a marriage. So if we have reactant A plus reactant B, they would pair up like a marriage and they would become product AB. And same thing with the visual representation here. We have a small circle plus a big circle, and at the end they are joining together in a synthesis reaction. And an example at the bottom is when we have Na ions and Cl ions that are going to bond together to become NaCl. These are a couple other examples of a synthesis reaction. So this is aluminum plus sulfur, and it makes aluminum sulfide. Type number 2 of chemical reaction we're talking about is a decomposition reaction. This is like a divorce. So if we start with product AB, like we ended with on a synthesis reaction, if we have product AB, then we are going to get products of A and B by themselves. So they're going to start the reaction together and then they're going to end up splitting up. You can see a chemical equation example at the bottom. This is also what a decomposition reaction could look like, is if we have calcium carbonate and it decomposes into calcium oxide and carbon dioxide. The third type of chemical reaction we will be learning is single replacement reactions. So this is exactly what it sounds like. It's when we have one thing that gets replaced. So you can see we have A plus BX. You can see that the X replaces its partner, so it swaps from the B and goes to the A. We have a picture and a chemical representation of this reaction below. So something to note, this is really important, when you are determining if something is a single replacement reaction, the reactants, the things that you will have on the left side of your yields arrow, will be an element and a compound. Always, always, always. The next type of chemical reaction we are doing is double replacement. And this is a lot like single replacement, except we are starting with 2 compounds and ending with 2 compounds. So you can see we have AX plus BY, and that becomes AY plus BX. So either the cations or the anions switch partners. As I mentioned earlier, when we're differentiating between single and double replacement, single replacement will always start with an element and a compound. Double replacement will start with 2 compounds. And we have an example for you here, and you can see that the cations replace cations and the anions replace anions. Our 5th type of chemical reaction is called combustion. And something to note about this is it's really easy to point out, really easy to remember, because carbon dioxide and water are always the products. They are the only products that will come up of this reaction. And it usually starts with a hydrocarbon and reacting with O2 or oxygen. And I will show you what this looks like. So a hydrocarbon is something that looks like this. It's when we have C and a random number and H and a random number. This is a hydrocarbon. We have a hydrogen, we have a carbon. Hydrocarbon. So it's always going to start with hydrocarbon and oxygen, and it's always going to make water and carbon dioxide. The amounts will change, like the numbers on the hydrocarbon will change and all the coefficients might change, but it looks basically the same for all combustion reactions. And the 6th and final type of chemical reaction we are learning is called acid-base. So we start with an acid and a base, and we get something ionic at the end plus water. So water is always going to be a product of combustion reactions and acid-base. You can see that we start with an acid. An acid is something that looks like this. Usually has an H in the front. So acids start with an H. Bases usually end in OH. Okay? So acids, this one's going to be my acid because it starts with an H. This one is going to be my base because it ends with OH. Then what we do, we take one of my hydrogens from the front here, we take this OH here, and we bond it up together to make H2O, water. Then whatever's left over, my SO4 and my sodium, make the other thing that's ionic. That is it, you guys. Go ahead and write down any questions you might have, and you can ask those at the beginning of class tomorrow.